Find the unit tangent vector and the principal unit normal vector for the following parameterized curve. And here we are given the curve parameterized by the vector valued function r of t with components 6 cosine of t squared, 6 sine of t squared. And this is such that t is greater than or equal to 0, less than or equal to 2 pi. Now, looking at our given vector valued function here, I notice we have a scalar multiple of 6. So I'm just going to rewrite this parametric representation of the curve by pulling my scalar multiple of 6 out in front. So we have 6 times the vector with the components cosine of t squared, sine of t squared. And as always, you don't have to pull that scalar multiple out into the front. You should get the same answer as long as your algebra is accurate and consistent, but having the scalar multiples on the outside of your vector oftentimes makes the computation easier. So that being said, let's go ahead and use this to find the unit tangent vector. So a quick reminder that our unit tangent vector is defined as the tangent vector divided by the magnitude of our tangent vector. So we'll use this definition to find our unit tangent vector. So first things first, we need the tangent vector. So differentiating the position vector, we have 6, that scalar multiple of 6 on the outside. Now the derivative of cosine of t squared leaves us with minus 2t multiplied by sine of t squared. So we need that chain rule. And then differentiating sine of t squared, we're left with 2t multiplied by cosine of t squared. And notice here that within the vector we have a scalar multiple of 2t. So I'm going to pull that out, which gives us 12t multiplied by minus sine of t squared, cosine of t squared. So that is our simplified tangent vector, and we'll now use this to find the magnitude of it, or to find its length. So here we go, the length of the tangent vector, we can keep that scalar multiple 12t out in front by that length of a scalar multiple property, and now we're multiplying by the distance formula. So we have minus sine of t squared squared plus cosine of t squared squared. And we can simplify this. So if you recognize what that inside is, by all means go for it. We can see that this is Pythagorean identity. Right? You could simplify that one step further and say, of course, that this is equal to 12t multiplied by the square root of sine of t squared squared plus cosine of t squared squared. And now we can really appreciate that there is Pythagorean's identity. So we know that this becomes 12t times the square root of 1, and the square root of 1 is simply 1. So here is the magnitude of our tangent vector. And so therefore, the unit tangent vector, which again we know is defined as the tangent vector, which we found to be 12t multiplied by the vector minus sine of t squared, cosine of t squared, and this is all divided by the length of that tangent vector, 12t. And so we see the 12t in the numerator cancels with the 12t of the denominator, leaving us with the beautiful final answer, minus sine of t squared, cosine of t squared. So here is the first part of our final answer. This is our unit tangent vector. And we're now going to go ahead and use our unit tangent vector to help us find the principal unit normal vector. So we are ready to find the principal unit normal vector. And again, let's keep in mind that this is defined as follows. We know that the principal unit normal vector, capital vector N, is defined as the derivative of your unit tangent vector divided by the magnitude of the derivative of the unit tangent vector. So we'll use this definition now to help us with our computation. So we need to find the derivative of the unit tangent vector. So using what we found above, this leaves us with minus 2t cosine of t squared, and then we have minus 2t multiplied by sine of t squared. And again, we see we have a scalar multiple of 2t. So pulling that scalar multiple out, we're left with 2t times the vector negative cosine of t squared minus sine of t squared. And we're now ready to go ahead and find the length of this vector. So we're finding the length of the derivative of our unit tangent vector. So keeping that scalar multiple 2t out in front, we have 2t multiplied by the distance formula. So we have negative cosine of t squared squared, which leaves us with positive cosine of t squared squared, plus minus sine of t squared squared, which leaves us with positive sine of t squared squared. And hey, we see Pythagorean's identity again. We of course know that this is 1. So we have 2t multiplied by the square root of 1, which goes to 1. And we're left with a beautiful final answer of 2t. And so we are now ready to find the principal unit normal vector, which is the derivative of the unit tangent vector, so 2t multiplied by the vector minus cosine of t squared minus sine of t squared. And that's all divided by its length, which is 2t. And we can see the 2t in the numerator cancels with the 2t of the denominator, leaving us with that beautiful final answer of minus cosine of t squared minus sine of t squared. And so this is our final answer for the principal unit normal vector. And I'll abbreviate PRIN for principal unit normal vector. And now, of course, we want to get 100 on our quiz or our exam. So let's take this one step further and check. So I'll provide us with more room in one moment, but we got to write our vectors down first. So what do we need to check in order to get 100? What are we checking here? Well, we're checking, we want to make sure that the principal unit normal vector and the unit tangent vector are orthogonal. So in other words, we want to determine, is their dot product 0? So let's see, we have the principal unit normal vector, which we found to be minus cosine of t squared minus sine of t squared. And we found the unit tangent vector to be minus sine of t squared positive cosine of t squared. All right, so let's go ahead now and compute the dot product to make sure we get 0. So we have negative cosine of t squared multiplied by negative sine of t squared, which leaves us with positive cosine of t squared multiplied by positive sine of t squared. And then we have, well, plus minus sine of t squared multiplied by cosine of t squared. So that leaves us with minus sine of t squared times cosine of t squared. And let's see here, we have a negative times a positive, which of course becomes negative. And these terms cancel each other out. Woohoo! Leaving us with 0. Hooray! So this officially lets us know that, yes, this is the correct principal unit normal vector, which is defined here. And this is the correct unit tangent vector.